We've looked at inequalities, or you guys have looked at inequalities before in your other math courses. An example of a linear inequality is something like 2x is greater than 8. It just has a single variable, nothing like x squared or anything like that. Now, there is a difference between inequalities and equations. You solve them similarly, but inequalities have an infinite number of solutions, while equations have a single solution. That's why you guys graph the solution for an inequality on a number line usually, because it shows it's not x equals 8, it's x is greater than 8. So it would have to be all those numbers greater than 8. So in our example, 2x is greater than 8, x would have to be greater than 4. So it would be everything above 4 could be a solution to this inequality. Equations just have a single solution. X equals this value. So you guys do have 4 types of inequality signs. The first 2 are greater than and less than. And those 2, when you guys graph them on a number line, they're going to be an open circle. When you graph them within a system of inequalities, you're going to use a dashed line. It doesn't include the value. So it's almost like everything up to that number. And then you guys have greater than or equal to and less than or equal to. And for those, you guys use a closed dot, and you would use a solid line when you're graphing it for systems. So we're going to practice solving a couple of these, and then I'll have you guys try. But you do have a rule to remember here when you guys are solving for inequalities. So whenever you guys multiply or divide by a negative number, you have to switch or reverse the inequality sign. Anytime you multiply or divide by a number that's negative, switch or reverse the inequality sign. So let's go ahead and look at number 2. 5 minus x is greater than 4. So I like to keep my inequalities or my variables on the left-hand side. So I'm going to subtract 5. The x is still negative. We have not gotten rid of that. 4 minus 5 is negative 1. And then we need to divide both sides by negative 1. So we end up with x is less than, because we divided by that negative number. When we divided by a negative number, we needed to switch or reverse our inequality sign. X is less than 1. So on your number line, I just usually put 2 or 3 numbers, the one I want usually in the middle. So it's just less than, so it's going to be open. And less than would be all the numbers to the left. So these would be all the solutions up to like 0.99999 repeating. It's just not actually including the value 1. And I don't care if you guys put the solution at the top or if you put it on the number line. Just because it's a little easier to see, I like to put it over the number line or like above it. So let's look at this one here. 6 times the quantity x minus 1 is greater than or equal to 2 times the quantity x plus 4 minus 4x. So I'm going to distribute first and then see what terms I can combine together that are alike. So 6x minus 6 is greater than or equal to 2x plus 8 minus 4x. So on that right-hand side, we can combine 2 and negative 4 and make this negative 2x plus 8. So I said I like to keep my variables on the left-hand side. So I'm going to keep the 6x over there and move the 6. And I'm going to do 2 things at once. And then I'm going to move the 2x over here to this side. So we get 8x is greater than or equal to 8 plus 6, 14. So when you guys divide, you get x is greater than or equal to 14/8, which if we reduce that is going to be 7/4. Again, I like to keep things in decimals, or I like to keep things in fractions. You guys can write them as a decimal if you want. So as a decimal, that'd be 1 3/4. 1.75. So if we use our number line here, I'm gonna go by fourths. So since it's greater than or equal to, we're gonna do a closed inclusive dot, and it's greater than that value, so to the right. So it's similar to solving an inequality or an equation. You just have to remember that rule up here about multiplying or dividing by a negative number. If you do that, make sure you guys reverse your inequality sign. And the reason I like to keep the inequality or the variable on the left-hand side, is because if the variable is on the left-hand side, so here the variable is on the left, here the variable is on the left-hand side. When it's on the left, the inequality sign actually points to which way you want it to shade. So when it's less than, it points to the left, which is the way we shaded. The second problem we did was greater than or equal to, pointing to the right, which is the way our graph went, to the right. That's another reason it's good to keep your variable on the left-hand side if you guys can. So why don't you guys try the two remaining then?